Hello, my name is Eris Regine with number metric 86428. In this video, I will present about introduction and objective. First of all, according to Smith, in Introduction to Chemical Engineering Thermodynamic textbook, shows that vapor-liquid equilibrium VLE defined as a liquid and vapor are both present in a balanced state. In a study conducted by Huang, shown naturally, Raoult's law described that the partial pressure of each individual component in a mixture of vapor is equal to the vapor pressure of the pure component multiplied by its small fraction in the liquid mixture at equilibrium. Raoult's law equation is shown as in this slide. Next, I will explain about objectives. This research project main aim is to develop a computer program that can illustrate a binary system of two species which conform to Raoult's law.
My name is Pavitra daughter of Panivelu. Now I will present about methodology to create an PXY diagram. First, we create an Excel spreadsheet to illustrate binary system benzene 1 and toluene species 2 at temperature 338.15 K. We enter the values of Antoine constants from table B.2 for both benzene and toluene, and we calculate the saturated pressure 1 and pressure 2 by using Antoine equations. And in column A, we enter the values for x1, and in column B, enter the values for x2 by 1 minus x1. In column C, we calculate the value of pressure using the equation stated. And in column D, we use Raoult's law to calculate the value of y1 and y2 calculated by 1 minus y1. And we use the results in spreadsheet to plot and graph while x1 and y1 on the horizontal x-axis and p on the vertical y-axis. For creating an TXY diagram, in column A we enter the values for x1, and in column B we enter the value for x2 by 1 minus x1, and we assume and enter temperature equals to 300 K in column C for all values of x1, and in column D and E we calculate the saturated pressure 1 and saturated pressure 2 using Antoine equations. And in column F, we calculate the value of pressure using x1 p set 1 plus x2 p set 2, and we use Golsick row to row to calculate temperature required to give pressure 101.3 kilopascal. And in column G, we use Raoult's law to calculate the value of y1, and we calculate the value for y2 in column E, where 1 minus y1. We use the results in spreadsheet to plot and graph where x1 and y1 on the horizontal x-axis and temperature on the vertical y-axis.
My name is Faustina Ana Anyai with metric number 83862. Figure above is a phase diagram on which the straight line is Px1 represents states of saturated liquid. The subcool liquid region lies above this line. The curve Py1 represents states of saturated vapor. The superheated vapor region lies below this curve. In between saturated liquid and saturated vapor line are the two phase regions where saturated liquid and saturated vapor coexist in equilibrium. The Px1 and Py1 lines meet at the edges of the diagram, where saturated liquid and saturated vapor of the pure species coexist at the vapor pressures P set 1 and P set 2. The Px1 line is the locus of bubble points, while the Py1 curve is the locus of the dew points. Vapor pressure is the balance between molecules leaving and entering a liquid surface at a set of temperature. It's linked to a substance boiling point. High vapor pressure means low boiling point. Both depend on the mixture's components. The TXY diagram displays composition for a binary mixture at a constant pressure. Benzene's boiling point is when its mole fraction is 1, and for toluene, it's at 0 benzene mole fraction. The upper curve is the dew point where vapor starts to condense. The lower curve is the bubble point where liquid starts to boil. Above the dew point is the superheated vapor region, and below the bubble point is the subcool liquid region.
To conclude, the binary mixtures of benzene and toluene were investigated at T equals to 338.15 Kelvin for pressure versus mole fraction and P at 101.3 kilopascal for temperature versus mole fraction. The aim of this research project was achieved where vapor-liquid equilibrium of a binary system of benzene and toluene was developed by computer program that can illustrate a binary system of two species that confirms Raoult's law. The objectives of this research project were also achieved as we learned to develop a computer program that can plot pressure versus both mole fractions at specific temperature, which is a PXY diagram, and to develop also another computer program that can plot temperature versus both mole fraction of liquid and vapor phase at specific pressure, which is TXY diagram. That's all from us. Thank you.